Well, hello internets, it's me again, and this time I have another train project for my dad. Here's a Lionel O-gauge track switch layout. As you can see, its purpose in life is to let you remotely direct the train down different tracks. I have a standard Lionel transformer here powering common on the outside rails. These two rails are hooked together through these metal shoes, and then the hot through the center rail, which is on little insulators. Now the other thing my dad has lots of are these little signal lights, and basically it's just two light bulbs with a common wire in the center, and then one wire hooked to each of these other two terminals, which are the red and green wires, which there's red and there's green. So what you want, oops, get that up right. What he wants to happen is somehow hook this to the switch, sort of like so. So when he flips the switch, they light up and stay lit. So right now, wiring it up this way, you can easily get them to light up when you're activating the switch. But this is a momentary single pole double throw switch. So as soon as you let go of the controls, it turns off. You could replace this with a non-momentary switch, but then you just burn out the coils, or potentially burn out the coils in these switch units, and they buzz and just all sorts of bad. So to fix that issue, let me just hook this back up a little differently. Oops, lost my connector. I made this little card. So this is a DC latching relay where the Lionel equipment all runs off of AC. So I had to do a little bit of electronic trickery to make this work. Please ignore the little cobble job on the back. When I originally designed these, I didn't have access to a working switch, and I ran into two issues. The first is I underestimated the amount of EMF kickback from these coils that operate this. So originally I used little diodes like that guy right there, and that back EMF would just pop them. So these are just higher current, higher voltage rated diodes to alleviate that disaster. If you notice, I don't know if you can see it on the back, this terminal block here is labeled the input. There's track power, switch A, switch B, and then these two side ones are labeled out 1, out 2, and there's common A and B, and then common A and B. So what we have here is basically a remotely controlled double pole, double throw latching switch. So let me hook this guy up real quick. These are screw terminals, so you can just take a screwdriver and put little wires in and tighten them down. For right now, I'm just using some alligator clips to make it easy. So for hooking this up, if you notice, these terminals here are different colors, and I don't know if you can see that. Let me see if I can get a shot. You see how this terminal has that metal plate underneath it? So this odd colored terminal, or the terminal with the metal plate, is hooked to track common, so the outside power rail of the track. Where these two terminals here are hooked to the two coils in here, which then both of those run back to the center rail of the track, which is track hot. So to make this little gizmo work, I need to sort of duplicate that. So I hook the track power terminal here to the middle rail, which is track power, and then the two outer ones, with a little bit of work here, hooked to the two coil terminals on the track switch. Now if I operate the switch, you can see one light glows brightly and one a little bit dimly. Again, that is due to the fact that this is two coils with a metal slug. So what you're seeing here is one coil fully energized, and then magnetic coupling between the two coils in the core, causing the second coil to power up like as a really, like a mini little transformer with a really bad amount of leakage. So the little bit of glowing is normal, just the fact of the matter of how this thing works. But the LEDs are just there to give you a sort of quick diagnostic of, do you got things wired up, is power getting to this guy. So that's that part. Now for hooking up the light, you just take common, and so first you take the common on the light power and hook it either to power or ground. It really doesn't matter. So in this case, I hooked the light tower to ground. Then you take the common terminal on one of these two switches and hook it to the hot line. Next, hook up your two lights to A and B. And now you can set these, you know, when the A side is energized here, the A switch should close over here. So there is a rhyme and reason to the A's and B's. So now as you can see, the light's staying on, and if I run the switch, it switches to the different track positions. Now another interesting feature about Lionel switches is they have an anti-derailing feature. So if the train is coming from this direction here and the switch is switched to this track, as it rolls into the switch, it throws the coils. Basically this little track section here and this track section here is isolated from ground and hooked to these two terminals. And as you can see, when the light is green, it's selecting this track, and when this comes in, it automatically switches the light to red to straight. And now if I go green, it goes this way. This is probably backwards color-wise. I just quick hooked it up. Usually green is straight and red is curved, but it varies greatly, and you know, it's just details at this point. So now if I come over here, switch it to the opposite direction, boom. Now these two switches, or these two terminal blocks, are electrically isolated from each other. So you can have two independent accessories on there on two different independent power sources, no problems. They're mechanically connected together, so when we select A is selected on both sides. So for a dual input accessory like this one, you know, you just use the A and B terminals and hook them up. Now I don't have one here, but there's also semaphores where the light's always on and there's a little mechanical or servo-driven or coil-driven semaphore arm. In that case, you hook up the terminal that goes to the coil to one side or the other, and then power, and then the other terminal leave open. So then when the switch switches in the direction you want, it closes the switch between common and that terminal and activates the semaphore, and then when you switch it the other way, it closes the terminal between common and what you're not using, which opens this terminal, and then the semaphore flips back up. The other thing you can use these for, since this is double pole, double throw, is if you have a DC motor, you want to run in one direction when it's switched one way, and then run in the opposite direction when it switches the other. You can hook plus voltage here, minus voltage here to the two common terminals, and then hook A to B to one side of the motor, and then B to A to the other side of the motor, and it will automatically reverse the polarity of the power to the motor every time it flips the switch. So maybe you have, I don't know, this is sort of for a more advanced model builder. So I can see where you had, like, you know, a dog chasing a cat, and then when you switch the switch, they'd change directions and chase the opposite way around a tree or something. There's a couple different ways that could be used. It's just a matter of the relay had the extra set of terminals on there, so I wired them out. These accessory terminals are rated for 2 amps max. In theory, if you put the two together in parallel, you can do 4 amps. Realistically, you probably, due to the way that current gets shared, you're probably limited to a little over 3 amps. If you do have a large accessory that draws a lot of current and it's greater than the rating of this, and you're worried about welding the terminals together, just get an automotive style relay. I don't have one. Oh, here. You know, get a large form factor relay like this, then you can use the pilot or the output terminals on this relay to close this relay, which is less than 2 amps current draw, and then use the high power output terminals on this relay to drive your heavy high current load. So, you know, depending on how you stack up all your options, you can do a lot of different things with this little circuit. Now before I close this out, voltage range. So right now I'm running about 19 volts, which is as high as my transformer will go. And as you can see, you can go crazy, no problems. Now at the other end of this transformer, I flip terminals back here to the B side. The min voltage is about 6 volts AC. So right there is as low as it goes. And if you notice, this is not even enough power to switch the switch on here, just because of the mechanical resistance. But the light is still doing its thing. So input voltage wise, basically 5-6 volts AC is your min. And it might be able to go lower. I just don't have a power supply to try it with, but it may be a little intermittent on that end. And then the max, 20 volts AC is probably as far as you want to push it. You might be able to get up to 25-30 volts before you do any damage, but it would probably shorten the life of the parts. So now that that's done, other thing, those that have worked quite a bit with these switches and Lionel train parts will notice is there was no buzz. These things are notorious for buzzing in a specific switch position. So let me hook this up real quick. And the reason being is there's a light bulb inside of this switch controller unit that lights up these little status lights. So if I do that, make sure nothing is shorting out here, and turn back up my power, you hear the buzz? What's going on here is, you see this is lit up now, is there's a light bulb between this common terminal, blue, and one of these two reds, just to get power to this light. So you always have current flowing from the track, through a coil, through the light bulb, back to ground. This caused me some headaches in my original design, because originally I just had a diode between the track power terminal and into the relay. So with that extra light bulb in there, I'd get a complete circuit from ground through one coil, through one coil of this relay, back through the other coil of this relay. It was power, coil, through one coil of the relay, back through the other coil of the relay, back down here, through the light bulb in here, and then to ground. So I'd always have a current path with the original diode setup going through these relay coils, and it caused the relay to chatter sometimes. So the fix for that was adding 2 diodes, removing the one diode on the common terminal, and put one diode on each of the 2 switch terminals. Because then when the current comes through, it's blocked by either this diode when the current's flowing in this direction, or it's blocked by this diode when the current flows in this direction. So let me just hook this up again real quick, and you can show that even with that extra light bulb, everything is still working. And you can go pretty crazy and it keeps in sync. There's also a light bulb in here which is currently burnt out, but that is strictly just wired across the track, common and ground, or sorry, power and ground, or power and common. So that has no effect on any of this stuff. But there you have it. Again, this was set up for Lionel train accessories. I have no worries. This should also work on American Flyer. I have not tried it because I don't have the equipment. As you get into the smaller gauges, if you're using AC power for running your switch accessory or your switch machines, it should work just fine, long as you're in that 6 to 19 volt range. if you're using DC power, then polarity into this guy does matter, and you want the track power pin to be positive and the two switch inputs to be negative. Otherwise this guy will not switch because the diodes will block it. Also in DC mode, your max voltage is going to be probably 12-15 volts. With AC, since the cycle is off, since AC goes plus minus, and the diodes clip off the minus sides, we get a half cycle of rest on the coils of the relay. So that lets me run higher voltages into the relay, versus with DC where it's constant and you always have that power going in the relay. Higher voltages will make it overheat faster. So that's everything. There is a new version of the PCB for this, so on the new version all these diodes have nice little pads, and when you put it together it's nice and clean looking, versus the little dead cockroaches I had to do on this guy. But there you have it. Dad should be pretty happy once he gets these all on the track and can just look across and see all these pretty little lights showing what state all of his switches are in. It's also nice because when you have a control panel full of these, even when they're labeled, it's way easier to look across your board and go, oh yeah, that's the one I want to switch, versus, oh, that's switching this one over here, that's not what I wanted. So that's all I got for today. I talked way too long as normal. So until next time, talk to you later.